Today you will learn all you need about AI, AGI, LLMs, and GPTs in simple words, and also why Sam Altman, who is the CEO of OpenAI, seeks $7 trillion to expand AI industry and possibly to create human-like intelligence, or AGI. Nowadays, AI is everywhere. It is in Google search, it is on Netflix, which provides you suggestions for a next show. Also, it's in the credit card fraud detection. AI algorithms are already in many processes and they were many years ago. But recently, in 2022, OpenAI released its ChatGPT 3, which kind of was a breakthrough this technology, and also it's enabled the public users to use its APIs and communicate with it. To briefly describe what AI is, it is like giving a brain to a computer, but instead of actual brain, it uses a set of tools and algorithms to process the data and give less or more accurate descriptions. And I'm going to show you how it works under the hood. But let's dive what's actually possible nowadays with AI. Now, let me show you a few simple examples on how you can use AI nowadays. So one of the well-known example is ChatGPT, and I'm going to show you how it actually works under the hood. But here it can do a lot of things, process the images, it can generate text, it can generate code. And in these examples, we are trying to generate an image, and I ask ChatGPT to generate an image of a cat jumping between the roofs. So as you can see, it gives exactly what I was asking for, and you can be more detailed, so you can get a more detailed representation of what you asked. So another example is Synthesia. This is an interesting service where you can actually create your personal AI avatar, and you can write any text you want for it to say, and also you can clone your voice, and it can talk with your voice, or it can use any other voices. So here's my personal Synthesia avatar, and I just create a simple text. AI can generate speech, text, images, music, code, and more. Okay, I hope you hear that one. So you can do that, and a lot of people are actually using it nowadays for content creation, like Instagram or YouTube. Now let's briefly touch what AGI is. And AGI stands for Artificial General Intelligence. And as you can see, current AI tools are good at one thing. It can generate images or it can generate text and so on. But AGI would be basically jack of all trades, and also it will have human-like intelligence or even better. For AGI, you would ask a task like optimize the global supply chain, or plan a mission to a space, or improve our current health industry with AI tools. It will completely redefine our world, but as of now, AGI is still a dream than reality. A lot of people are speculating that AGI will be soon, but in reality, no one certainly knows how to build it, or even if it's possible to build it. Let's quickly dive into AI. So this is just a simple diagram to illustrate where the things are, and those are basically subsets of AI. I just draw simple three subsets of it, but it has much more subsets, but will be enough to understand the core concepts. Under the AI, we have a subset which is called machine learning. And this is an area where AI is focusing on learning from the datasets to train the models. For example, we would feed enormous datasets to a model, and it would be improving itself based on the target output. But we'll talk about this a little bit later. Then after that, we have deep learning, and deep learning area is inspired by human brain. Those are the layers of algorithms to recognize data patterns like text, images, and sounds. And it has many different types of algorithms or models that are currently available for us. So for example, we do have a model which works with the recognition of images. And will be completely different architecture compared to LLM, large language models, which is an example of ChatGPT. And under that, you could see that I wrote LLM. This is another type of model, which is based on the transformer architecture, which gave AI its current state of popularity. And we will talk about transformers a little bit later in this video as well. So now let's dive deeper into LLMs. We're going to discuss just an overview of what's a model and how it works. LLM stands for Large Language Model, and it is based on transformer architecture, which was published in a research paper in 2017, which is called Attention is All You Need. After that, former architecture became fundamental of a lot of neural networks nowadays. So we could say that was a breakthrough technology, and we exponentially start developing a lot of tools based on this architecture. So this is the architecture of transformer, and we're just going to dive into a simple stages which are most important for this model, and then later I can make another video describing this a little bit more into details. But we do have stages which is called tokenization. Detokenization is very similar to tokenization as well. And then another stage is input debating, positional encoding, and multi-head attention. Now let's talk about the first step, which is called tokenization. It simply means we are converting the regular sentences into numbers because we're working with the mathematical models. They do not understand the sentences or words that we humans usually do. So we have to convert them into some type of numbers, which is also called tokens. Those are usually already predefined for each word or for any characters that we have in our sentences. We already have a specific token that we would convert into. And then we will go from there into our second step. The second step, which is called embedding, helps the model to understand the meaning of the words relatively to each other. Now let's dive deeper a little bit into embeddings because this will give us an idea of how the computers actually understand the meaning of the words relative to each other. And we can see here that we do have a three-dimensional space. But the computers usually use much bigger spaces, such as 512 or even bigger. But for just simplicity, we're going to use three-dimensional space. So we've had three words, dog, puppy, and animal. And each word has its own set of coordinates. So those coordinates are actually representation of where those words stands compared to all other words. So for example, we can see here that the dog is very close to puppy because they're relatively similar to each other, but the animal is a little bit further away. And the same thing will apply, for example, if we have a completely unrelated word, for example, like airplane, which might be somewhere around here, and it will be even further away for those words. This is basically how the model understands how these words are similar to each other. So now the next step, which is called positional encoding, helps the model to understand where the words are located within the sentence. Now know what is the meaning of each word relative to each other and the position of those words or characters within the given sequence of the words that we're feeding to the model. Let's talk about attention, which is the core and most important part of the model. This self-attention mechanism in the model takes the sequence. For example, we have here the cat sat on the mat because it was tired, dog. And each word has its own meaning to all of the words. For example, as human beings, we know that it in this example relates to the cat, but the computer doesn't know anything about it, so it asks, what is it? And this mechanism helps the model to understand what is the relation between all of those words or characters. In this example, we can see that it has a little bit stronger weight with the word D. It has very strong relationship with the cat, has a little bit smaller relationship with sat, and so on. And then every word has its own weighted relationship. This was example of it word. Also, the Z will have the relationship cat, sat, on, and other words. And at the end of the day, we'll get this relationship between all of the words, which call self-attention head. And that's how those models are able to track very, very long paragraphs and keep the meaning of all of the characters in the sequence. This mechanism was a breakthrough that was published in 2017 in the research paper, Attention is All You Need. This is an online tool that can represent how those weights are combined to each other. So as you can see here, each word has its own weights to another word, and all of them are creating this attention head. And then the model creates multiple attention heads. For example, ChatGPT-3 have around 100 attention heads, and each attention head has its own meaning. For example, this have a synthetic relationship, subject-verb dependency. Another might have a rhythm relationship. How good is the rhythm between each word? Then another one has a long-range dependencies. So how, for example, word can relate to word may or not. And for example, word repetition or similar sounds. Those attention head helps the model to have a meaning to the sequence, and it will give the model an ability to give the most accurate output. Another aspect worth mentioning is that those models have parameters. Those parameters are helped to create those attention heads, and the parameters are created and adjusted during the training process. So more parameters it has, the more likely the model will generate more accurate output. So we could make a quick comparison that the model ChatGPT-1 had 117 million parameters, And ChatGPT 3 had 175 billion parameters. So as you can see, that they're trying to increase the number of parameters to make more powerful models. After the model created those multi-head attentions, then the next step is to refine those output. Feed forward step, it takes the complex patterns of multi-head attention, processed with additional computations, and produces a more refined representation of it. In the final stages of this model, which is called linear and softmax, are helping the model to give a probability, which ranges from 0 to 1. So each character or a word will have its own probability number, which help the model to provide the next output. If you notice when you work with ChatGPT, it doesn't give you the whole output at one time, like a sentence or paragraph or so on. It will provide you one word at a time. So that's why it works like this. Then the next stage, which is the final stage, which is called de-tokenization. This is when we convert our tokens into human readable format, like a text. Let's discuss how the model actually gets trained. At the very beginning, we adjust those parameters, as we discussed earlier, randomly. And we also provide the targeted output that the model should compare its results. So we give the model certain inputs of data, and the model tries to give the best predictions. After that, it compares our targeted output with its prediction, and if they're very different, then the model adjusts its parameters to better predict the outcome. So this process repeats over and over again until the model gets better and better. And this happens with enormous amount of data and a lot of computational power to train the model. That's where this name ChatGPT comes from. G stands for generative, means that it generates output. P stands for pre-trained, and T stands for transformer. It costs a lot of money to maintain and train those models. That's why Sam Altman, who's the CEO of OpenAI, was seeking $7 trillion to create those chips and maintain the data centers in order to create that powerful AI. I hope this video was pretty informative and you got the core concepts of AI. And please like a video and comment below if you have any questions. See you later.